Okay. Um, Hello again. We're going to talk and continue talking about the autonomous and now how the autonomous vehicles will be in our life. And that's the reason why we have now an incredible roundtable. Let me tell you that perhaps is the unique moment that you will combine the best of the world in terms of how can you put the self-driving car on all the autonomous vehicle in our life. Will be a big debate about how we will implement all of that. During all this morning, we were talking about the vehicle with infrastructures, the vehicle in relation with other vehicles, the behavior of the customers. And we have now the opportunity to listen how artificial intelligence, how companies like Bosch, how the industry is working in this direction in order to transform and to implement our vision to develop the self-driving car in our life. For this reason, let me offer the stage to Rafael Boronat. Rafael Boronat is the delegate of the president of the Sociedad de Técnicos de Automoción, and he will manage all the debate. Thank you.
Thank you. Thank you very much. Good afternoon, and welcome to this session of the Technical Society of Engineers Vision. Then we are going to deal with a subject that today is in the mind of everybody, and that's the reason why the Motor Show of Barcelona was really organizing this connected hub, really to deal with these so advanced technology subjects. Then first of all, let me say that this conference has been organized on behalf of STA, that is the Sociedad de Técnicos de Automoción, that is a society that is a member of FISITA, that is the Worldwide Society of Engineers, and STA has been cooperating with the Barcelona Motor Show for more than 20 years ago. Then initially all the conferences we were organizing were really dealing with vehicles, but through the years, then the electronic was incorporating afterwards the electric vehicles, and nowadays all these very, very interesting items related to the connected hub and connected vehicles. Then the first speaker will be Vicente Aguilera here. Vicente Aguilera has been all his life working for the automotive industry, and he continues working for the industry and many other items. And he is industrial engineering from the Polytechnic University of Barcelona, and nowadays he's as well the president of the Catalunya, the circuit of Catalunya, and as well of the newly developed initiative is the Clúster of the automotive industry in Catalunya, and he's the president as well. And he spent the majority of his career in working for CIAC as a technical director in many fields, and mainly as well in the racing activity. And afterwards he was in Ficosa, in the executive board of Ficosa as well, and he's working as well for Conforsa, that is a supplier of the industry for forging and other heavy-duty parts. And as well, he is acting as an advisor and member of the board of many of the companies. Then he has a very long experience, and he may provide us with a very broad view of this. Then, before he will make his own speech, then we are organized that everybody will have a speech between 5 and 10 minutes, and then with some presentation, and later then we will have some debate, and we will open some Q&A. Then I have to ask our panel that he will respect the time as much as possible, then as a moderator. Then I have to say that, as I was telling before, just as a very brief introduction, that let's say today's the car, everybody understands that the car from the mechanical point of view, the body, and the vehicle itself is really performing very well, and sometimes it's really sometimes seems that all these kind of connections you see is like fashion. It's not a fashion. It's because the car, and today the internal combustion car and the electric vehicle are really achieve a very high perfection in all the utilization and the units and components and technology and the respect to the ecology and the emissions, and so that always the automotive industry has been in the forefront of technology and society. That's why today one of the main interests in many respects is the utilization of this vehicle. And then this utilization in respect of mobility means how the car could improve safety, reduce accidents, improve efficiency, and many other things. And that's why the industry and the university is developing self-driving cars that needs really to be connected with the infrastructure, with the other vehicles, with the environment and everything. And that's why we are here. We are here because our top experts panel are going to explain us what is the state of the art in the technology. Then, Vicente, please. Yes.
No. O sea, que introducías a todos ustedes.
No. Uno.
Okay, thank you very much, Rafael. It is a pleasure to be here. Good afternoon to everyone. Well, we are in front of a big challenge for all the automotive world. A big challenge because the technology for the autonomous vehicle is available. And it's something that is new for the automotive business. Technology is available, but the difficulty is to implement the different levels of autonomous driving. That's one of the key that all the companies should face, the big challenge to go growing in autonomous performance in the car with the technology that everybody on this table, on the floor, knows. Camera, radar, LiDAR, other sensors, all we know since many years ago. But we need to put all together and to perform under 99.9999% of the times. That's extremely difficult. That's extremely difficult. That's the reason that the people has the feeling that we are very slow working, because we are not reaching the levels that the market may expect today. And the reality is that the few cars are showing the first level of performance in terms of autonomous, and it will take time, a lot of time, because to prevent or to plan and to manage all the situations with drivers of 18 or 81 years old, with a different 40 kilograms or 140 kilograms, with men and women, it's extremely complex. And that's one of the key. That means that we will not need too many mechanical engineers. The mechanical engineers has made his work. We need a lot of people working in the microprocessors, in the capacity of processing, a lot of people working in software, a lot of people working in testing. Testing will be also a huge work to test under all the conditions that are so difficult to put all together that it will take time. That means we have a lot of work in front of us. There are a lot of opportunities. And of course, if we reach all the levels that we expect, reaching the level 5 in some years, I would say that we are in front of a new era of mobility. Because it will be two types of mobility. The automatic mobility and I would say the traditional mobility. Because some people will like also the traditional mobility and will not share the autonomous mobility. That means that we go to a more complex world, and of course very challenging and it's a passion to see how the technical work in this autonomous vehicle will develop next years. Thank you very much.
Okay, thank you, Vicente. Then the next speaker is Mr. Gilbert Gagner, that I will introduce him. He has 25 years background in the financial technology sector, and he is now exploring robotics and technologies for autonomous vehicles. Over the course of his career, he held R&D, consulting, business development, and senior management roles within a number of financial software companies. These include McDonnell Douglas Information Systems and Fermat, a company he co-founded in 1996 and was acquired in 2008 by Moods Analytics. With 30 years of international experience, he recently acquired Robosoft, a French leading player in the field of service robotics. The company applies its know-how to automated transportation of people and goods, defense, security services, cleaning services, and people assistance. Their robotized vehicles have transported more than 3 million passengers. Robosoft is in partnership with Groupe Ligier and designed a 12-person transport autonomous shuttle called EZ10. Now this shuttle is sold in the market by a new company funded by Gilbert named Easy Mile, with R&D located near Barcelona in Toulouse. His company, nevertheless, is operating successfully worldwide, but Mr. Gagner's home base is Singapore, a little bit far away from Toulouse, but in Singapore.
Wow, that was a long introduction. I did not remember I've done so much. Okay, never mind. I'm going to spend just a few minutes to explain the concept of Easy Mile. And to begin with, if you look at these slides, I think it summarizes pretty well what we are trying to do at Easy Mile. On the left-hand side of the screen, you can see the situation of a city now. And on the right-hand side, this is basically what I would like the city to be in the future. I've been living in huge cities since I'm young, and to be frank, nowadays I'm really bored, really sick of the traffic congestion, and I would love commuters, to give up their private cars and use public transportation instead. So the question is, how do we achieve that? And the main challenge we are confronted is the door-to-door challenge. If you start using public transport, very likely you will have to walk from your doorstep to the next transportation hub, and then maybe take a bus, tramway, whatever, and very likely you will end up walking to your office. So that creates two different issues. The first one, you still have to walk. I've been living in Singapore for 12 years. I can tell you something. If you walk more than, say, 300 meters, you're completely wet. Your shirt is totally wet. 35 degrees Celsius, 90% humidity, you don't go to the office. So at the end of the day, you don't walk. You grab a taxi, you take your car, but you don't walk. Secondly, in terms of time, if you have the choice between spending 1 hour in public transport versus 10 or 15 minutes in your car, you use your car. And politicians cannot do anything against that. In Singapore, public transport are fantastic. They are cheap. The price of a car is about 3 times what we pay here in Europe. Every time you use your car, you have to pay. There's a road toll, like in London. It's a nightmare, but people don't give up their car. They don't use public transport. So how can we handle that? So my vision for the future is mobility as a service. I hope that one day you guys can use your smartphone in the morning to say, look, I'm here, I'm at home, I want to go to the office, I want to start now. Please create a journey for me. And probably your journey will start with an automated shuttle that will fetch you at your doorstep, will pull you together with some other passengers to take you to the nearest transportation hub. It might be a bus, and then the bus will take you to the metro or to the train, and then at the other extremity of the journey, another automated shuttle will fetch you at the train station and will take you with some other passengers to your office. And for that, you will just pay one ticket. Because another concern is that all those transportation modes are nowadays operated by different companies. The bus company is not the same as the metro company, that can be different from the bike sharing company. But ultimately, what you want to do is something hassle-free. I pay one single ticket from my home to all the way to my office. So the key enablers to that problematic are two things. You need an automated shuttle to deal with the first and last mile, and you need a multimodal platform that can handle your entire journey using different transportation modes. So what do we do at EasyMile? We do the first and last mile problem. So we have developed both the software and a shuttle. So this one is a 14 passengers people mover. It operates at low speed. And this is not science fiction. We have currently quite a number of vehicles in operations around the world. So you can see here a few iconic buildings. I love architecture. So some of you can recognize maybe Gardens by the Bay in Singapore, the Rolex Learning Center in Lausanne, Switzerland, the Burj Khalifa, Dubai, and so on. And we have a total of 40 vehicles now doing experimentations in 14 countries. So far, we have 0 accidents at our counter. I mean, we keep moving. We will start very soon in June the production of the commercial version of our vehicle. So far, there were prototypes. So I hope that in a few years, this idea will become true. And that's it.
Okay, next speaker is Jean-Luc Maté. Jean-Luc Maté is based in France, is Vice President Strategy and Development of Continental Engineering Services for France and Spain. He is recognized as a European pioneering entrepreneur and innovator of modern automotive electronics. Jean-Luc took part in the creation of the Renault-Bendix joint venture in Toulouse in 1979. For more than 38 years, he introduced major vehicle innovations in all worldwide markets. In 2017, this year, he remains convinced that the automotive industry and smart road transport have a very bright future if all stakeholders in the transportation ecosystems are working to build a clean, connected, autonomous and affordable transportation system. Besides this, he has been participating in several platforms such as AirTrack, Automec, Europa, Euripides, and he is director of the Society of Automotive Engineers, CIAC, and he's a very good friend of STA in Spain as well, because it's very important that all the engineering societies will be very, very well connected in Europe. He has a statement, he has given me a statement I'm going to read, that he says that he believes that the first North-South European corridor for autonomous transport of persons and goods will cross the French Occitanie and Spanish Catalonia for the benefits of all Europe. Thank you.
Thank you, Rafael. Thank you so much. So, ladies and gentlemen, I am the technology provider. If I listen to Mr. Aguilera, everything is existing.
We just have to apply it. Okay, Vicenç. So, I have a definition about, when we talk about autonomous, there is a definition that I think could be interesting. Just after the presentation of Mr. Aguilera, we can understand it very clearly. Everything, somewhere. What does that mean? Provide autonomous support to the driver. That means everything, but only in some special conditions somewhere. And I think the ultimate state of everything somewhere is a shuttle of EasyMile that is providing full driverless autonomy, but somewhere. Something everywhere is where we are in the automotive industry. We provide a certain degree, certain level of automation. We are not providing the full level, but we are providing this level, and this is why the automotive market is so difficult everywhere. This is what we need to sell. We cannot sell something that is not capable to be handled everywhere. So, if you look to this chart, you will understand the complexity that was described in the introduction of Mr. Aguilera. You see how much ingredients we need to combine, we need to simulate in order to be in a position to integrate the millions of use cases that we need to afford when we will drive millions of kilometers with millions of drivers that are all different. This is the difficulty. We need to modelize, but to modelize what? The driver, the vehicle, and the most complicated is the environmental model. We are not driving in the same condition if you are in Japan, if you are in the United States, if you are in Barcelona, or if you are in Paris. Completely not. So, in order to get a database for becoming really providing something everywhere, you need to drive millions of kilometers. This has been the first starting point when really we decide to attack the subject in Nevada. The Nevada state offers us the, whoop, how it works. The movie is not working. Okay. Okay, so Nevada offers the first possibility. I think it was in 2012 when we start driving more than 24,000 kilometers in public roads in Nevada. And this was a starting point of intensive driving. You can imagine if you are driving 24,000 kilometers with only one car, now you are driving with a lot of cars and continuously you can really get some use case which are important in order to collect what has to be simulated with the new software function and with the new architecture. We do the same in Japan. We do the same in Japan. Oop. Here is Japan. Starting 2014, so we are 3 years before intensive road test in all public roads in Japan, in all conditions. We drive in different conditions, also days and night, to accumulate data. This data will be after collect, and the use case will be simulated with the new software version of the new ECU that will drive the autonomous driving function. This is the only way to collect the possibility to simulate autonomous driving. So, by doing this, we are on the way to really be safe in driving condition in highway, but we are far away to be able to drive everywhere. In order to give you the roadmap of Continental Automotive, this is what you need to have in mind. We are in 2017. 2017 will be really the year where there will be a lot of cars, and there is here in the connected street the possibility to test driver assistance system and a lot of safety function like emergency braking and all these type of things can be tested in 2017. When we are talking about a new level of automation, taking into account the link with the cloud, this is something that will appear in 2020. But when we are talking about really the level 3, and we are far away, level 3, we have to wait until 2025. And you see after, when we are dreaming about everything everywhere, in 2020 we believe that we will be able to have a really good condition of autonomous driving in the highway in the 2030, excuse me, and in 2030 plus, I think perhaps we will see the possibility to have the level 5 of the autonomous driving. So how many engineers have to work from now to reach this level? If you look carefully to the condition of the hiring process of engineers in the automotive industry, in all car makers, in all equipment makers, we never see such amount of hiring process in our automotive industry to be able to handle this challenge. This is really something that we never face in our life. In parallel to this, remember, we are also changing from thermal vehicle to electrification, and we are on some case also changing the electrical vehicle to some application with the hydrogen. So this is clear that we never face in the automotive industry so much. So we have not the right amount of engineering power to go faster than this chart. And this chart perhaps can be optimistic. So please, go to drive with the current function and year after year, educate you with the advanced autonomous function that will come level 2, level 3, in order to be really understanding when and why we can be everything, everywhere in the future. Thank you.
Thank you very much, Jean-Luc. Then we are going to change from institutions and industry to university. Then it's a pleasure for me to introduce Professor Raúl Rojas. He is Professor of Artificial Intelligence and Director of the Dahlem Center for Intelligent Systems on the Freie Universität Berlin. Well, he's coming from Mexico, although living in Germany. He has been working on robotics and autonomous cars for the last 20 years. Professor Rojas received the Technology Transfer Prize of Berlin in 2008 and was named Professor of the Year in Germany in 2015. Then congratulations, Mr. Then he was awarded the National Prize of Technology of Mexico in 2015, and his autonomous vehicles have been licensed to drive in Germany and Switzerland. In 2015, one of his vehicles drove autonomously from Nogales to Mexico City in Mexico, a stretch of 2,400 kilometers. Then, Professor.
Thank you very much for the presentation and for the invitation to be here. And I'm just going to add a few things to what my colleagues had said before. I'm not going to repeat everything. I just wanted to show you this picture because it's from 1918. It's the earliest picture I have been able to find about autonomous cars. It was published in Scientific American in that year. And you can see that there is no driver in the car. So the people in the car are reading or are watching, but nobody's driving. So actually the dream of having cars driving by themselves, of having autonomous cars, is now almost 100 years old. So the dream is old, but the technology is new. So what changed in all these 100 years is, of course, that we got computers. There were no computers at the time. We got laser scanners, we got video cameras, we got all the sensors that we use today for driver assistance systems and which are going to be used also for autonomous driving. So the dream is very old. The technology is now coming to a point where this dream can be realized. So I think that if you look to the past, we can see that in the past, the driver was in the center of the car. So we had electronics all around the driver, but the driver is the one doing all the manipulation of the different parts of the vehicle, the steering wheel, the brakes, the accelerator, and so on. Actually, now in the present, we don't have the driver alone. We already have a co-pilot in the car. The electronics is like a co-pilot in the car because you have already systems that can stop the car if you are going to produce an accident, or there are systems that keep you safe on curves. So if you are going on the highway and your car starts leaving the highway, the electronics can measure that and can stop braking the individual wheels so that your car stays on course. So we already have the driver with a co-pilot. And the future is what you see on the right. So we are going to the situation where the computer is going to be the driver, where the different driver assistance systems are becoming so good and so complex that at some point you are going to be able to press a button and then the car will be going by itself. We have a car in Berlin. We have been driving with this car for several years. And I always say that this car is more like a laboratory. It's not really something that you want to produce commercially. It's more like a laboratory for trying different sensors. We have radars covering almost 360 degrees around the car. We have laser scanners covering also 360 degrees, 3 laser scanners in the front, 3 in the back. We have a rotating laser scanner on top of the vehicle, gives also 360 degrees of coverage, and we have 9 video cameras. The 9 video cameras are covering also everything around the car. You don't need all that technology for driving autonomously today, but as I said before, we want to combine different sensors. We want to see which sensor is better for some applications than another sensor. What about the highway? What about the streets in the city? What kind of sensors make sense in one environment but not in the other? That's why we have so many sensors in this laboratory on wheels. Now I think that there are going to be two changes in mobility in the next few years, in the next 20 to 30 years. One change is going to be electricity, the electromobility. So going from internal combustion engines to electric engines. But the other one is what we already saw in one of the presentations. We are not going to need a car for driving around in the city. We are just going to have a mobile device. Using the mobile device, we can call a taxi, and that taxi is going to take us from one place to the other. The taxi driver is going to be a computer. That's the only difference with a shared taxi driving system of today. So the car can be autonomous so that you can save money. And our vision of the future is that you are not going to have cars parked on the streets. So the cars can be free of parked cars. We will have more space for bicycles, more space for pedestrians, and we can also reduce the number of cars in the cities if we share the utilization of the vehicle, as we saw in the presentation of Easy Mile. One other change that for me is going to be essential and is going to come faster than autonomy is car-to-car communication and car-to-infrastructure communication. The law for making car-to-car communication mandatory for all new cars in the US has been drafted. It's going to be approved maybe this year or next year. And then all new cars sold in the US are going to have need to have car-to-car communication. So once you have to build cars with car-to-car communication for selling them in the US, that means you have to you have to build the same cars for selling them in the whole world. Many people ask me, for example, in Mexico, so people don't really believe that the technology is going to come to Mexico, and they always ask me, are we going to really have autonomous cars in Mexico? And I always tell them, of course, because the cars that you use in the US are going to be built in Mexico. That's why they are going to come at the same time. So the car is now, the automobile is now a global product. It's a product that goes everywhere, that's sold in all countries. And that's why the technology is going to diffuse so fast. And especially telecommunications is going to be one of the big changes in the next few years. And I think that making this connected hub at this fair is a very good idea, because it's the only one fair that I know about where this is the center of the exposition. As was said before, we have been driving many thousands of kilometers. This is the drive that we made in Mexico, from the border to Mexico City. It was 28 hours of driving for 2,400 kilometers, going through 5 cities. So it was not only highway, it was also crossing through 5 cities. And I will just finish with a video of the kind of reconstruction that we have in the car when the car is driving. In the bottom, you see some of the sensors that we use. This is an actual drive in the city of Berlin. We have been driving in Berlin since 2012. We can drive stretches of 80 kilometers in one single day, going through 125 different traffic lights. And we are always developing the technology. And right now, we are working on driving without a map. Until now, we have always driving with a map. In the future, we will be able to drive in a city without a map. So you just tell the car, follow that street until you hit the end of the street and go to the right and go to the left and you will have a ride. That's one of our projects today. Thank you.
Rojas, for your very interesting explanation. And then just to finish with the panel, the next speaker will be Mr. Ricardo Olalla. Ricardo Olalla is Sales Vice President for Mobility Solutions at Bosch, Spain, and also leads the Engineering Services Department. He owns a degree in physics and has been working for Bosch for more than 25 years. He started as application engineer for ABS and TCR and then moved to engineering and project. Project of management for wiper systems and electrical drives divisions. He has worked in these areas in Germany, USA and Mexico as well. And now he is located in Madrid. He presides the OEM Business Committee at Cernauto, that is an association of Spanish suppliers, and is a member of the board of ASEPA and the Automotive Master at INSEA. Then Ricardo, please.
Thank you, and thank you to STA for inviting me. It's working? Can you hear me? Okay, thank you. So thank you for inviting me. I have no presentation, so I will try just to lead you through what we are doing at Bosch in this area in autonomous driving, and at the end we will try to show you a short video that, let's say, will somehow illustrate where are we on this development. Everybody talking about autonomous driving, and it has been already said that this is because the technology is there. And maybe the technology is not yet there, and we agree on that we are working and a lot of engineering power is still needed. But the base technology is already there. So the sensors, the computer power, the communication to be able to connect the car in a reliable and efficient way, the robotics technology, and you will see on the video the knowledge to be able to make the communication between the human and the machine. At the end of the day, an autonomous car is a robot. It's a robot on wheels. And we need these robots that they communicate and they work together with humans in a proper way. So we have the technology. And the other question that we have is, do we have the demand? Are the people really ready to use autonomous cars? We see two things. Oh, sorry. We see two things regarding the autonomous car. One is the need of the people. So everybody is dreaming about, we need really we will enjoy to don't use the time for driving, but use the time for other things in our commuting, in our daily work. So there is a need from the people, and don't forget, the autonomous driving is now as close as it is because we have been working on assistance systems that are useful for traffic safety. This we have to say as well. When we are fully on automated driving, our traffic safety record will be much better. So there is a demand from the people, and what we are seeing now, there is a demand from the companies. There is a business model for autonomous driving, and this is actually, on our view, speeding a lot the development for autonomous driving. There is the vision of all those car sharing and mobility services, and we have a very nice example here on the round table that with this technology you can offer mobility in a very convenient and economically efficient way. So there are companies out there that are dreaming, and not dreaming, but working on getting to level 5, because level 5 will be the best service that they can offer. So what we are seeing as a technology provider, we have the OEMs, so the traditional car makers. They want to get into that. They want to go into this future market of, let's say, robo cars, but at the same time, they need to offer their customers every day a better car with more ADAS, so advanced driver assistance system. So this is one path that we call of evolution, and we are working, because at the end of the day, we all, the consumers, will need to pay. And certainly we are going to pay for advanced assistance system, for having the possibility when there is a traffic jam, where we are on a highway, not really very exciting to drive, to leave control to the car. But maybe we cannot afford the full technology for every situation everywhere. So this is where the new companies come into place, and this is where this, let's say, new power into the market is coming, and there is this demand for technology to be able to provide to those mobility service providers, those robotaxi, let's call it that way. So what are we doing at Bosch as a technology provider? I would say you have Conti has shown a nice roadmap that I would say is not really very different from what we see. So I think there is a consensus, and we were talking at the beginning that there is a certain deception for part of the public, because some marketing people were showing that the autonomous driving was almost there, and there is still some engineering work to do. But I think the industry, there is a consensus on this roadmap, and this is where we are as well. We base our business on this ADS, so in those driver assistance systems. We have recently presented a collaboration with NVIDIA to do a special car unit for autonomous driving based on artificial intelligence, which is a key issue and a key technology in order to provide autonomous driving. Very important as well to have very accurate maps with, let's say, things like radar footprints and things like that that will help our autonomous car to navigate. And recently, I think it's known by everybody, we have presented a collaboration with Daimler-Benz, where we somehow disclose our roadmap. And again, we made the difference between the private consumer and these robotaxis that will be in the near future available. So I would like to finish by showing a video. I don't really know if you can turn on the video. That shows one of the latest tests that we did on autonomous driving. Oh, yeah. Okay, I guess that's the problem when you are the last, so sorry about that. Oh, conecta al otro. No. Okay. So I think I have to give you the word. Okay. Sorry about that.
All right, thank you. Okay, thank you very much, gentlemen, because all your explanations and so has been very, very interesting. I think that there are probably a lot of opportunities to ask questions. And then I'm going to, let's go to organize now, because we have time enough. Then I will propose first one question to all of you, but afterwards I will invite you to be moderators as well, and then ask each of you a question to the rest of the table. And then if from the assistants there are questions, they may use this opportunity as well to ask in the time every panelist is asking this question. But let me say something that is a bit out of the frame. It's not the first question, but it's out of the frame to Vicenç Aguilera, because yes, as he is the president of the Catalunya circuit, and this weekend is the Formula One racing in Barcelona, Gran Premio, and then I was thinking in the meantime, say, okay, by when the Formula One will be autonomous?
My God. Well, it's not a difficult question. It's a very funny question. I say, good to put this question to me, but I think one of the attractions of the Formula One or the motorsport in general are the drivers or the riders, no? Without Hamilton, without Alonso, or without Marquez, the motorsport will be not the same probably. That means I think I would suggest that we keep far away from the autonomous vehicle, but for sure we need to plan that in short term we can plan races without driver. But we should be we need to be very careful not to mix the today's architecture of the races with the new concept. If we make races without drivers, the races should be different. We need to focus in a different way. All you are engineers, or more or less engineers, or more or less linked to the technology, and there is the typical mistake when you are able to make a part with a material or with another material, we try to use the same design. We should avoid this mistake. If we make races, that is possible today to make races without driver, we should make a new form, a new shape of races in order to make really attractive the technology for the people.
Okay, thank you very much. Then I'm going to ask my first question to all of you, maybe one by one, and then the question will be common for all of you, but maybe you may start. You may start. Then it is really true that all these, let's say, advances in things like recognition and tracking of objects, management of data, localization, mapping, advanced artificial intelligence, algorithms, and many other things that even now are incorporated in the cars, that is level 1 or level 2 or 1.5, has been developed through the years, and now are part of the autonomous vehicles. That there is already a tangible benefit in technology in the hands of customers. No? But nevertheless, even if the technology seems available or almost available, and there are some reference dates for introduction of level 5, that is the full autonomous vehicle. Nevertheless, sometimes one have the impression that in every conference this reference date is delaying. Then, well, initially it was 2020, afterwards even 2020 declared by the top management of the high industries, even Ford or Nissan, Renault, and then now to 2025. And so then how do you see the reality? Is in reality technology is available? There is some reluctance from potential customer, or there is some implication of the investment in public infrastructures that may be needed for some of the really utilization of these vehicles that is really delaying. What are really the factors apart from technology?
I mean, the full autonomy everywhere. I mean, everywhere, anytime, regardless of the weather, regardless of the environment, is something that is incredibly difficult to achieve. And if you ask me when it's going to be ready, I would say, what about never? There's always a level of difficulty that you cannot match. One day you can be comfortable, let's say, driving in the streets of Mountain View, California. But Mountain View, California is completely different from Southern Europe. And if one day you manage to match the driving in the streets of Barcelona, you're probably far, far, far away from being able to drive in the streets of Mumbai or New Delhi. And driving in the streets of Mumbai during the monsoon season is probably one step forward in terms of challenge. And literally level 5 means there's no limit. The car can do everything anytime. And I would say that's not going to happen.
Okay. Is any question for Mr. Gilbert? Well, if not, Jean-Luc, it's your turn.
When you discuss with people in the aeronautics sector, they are very excited by what we are doing now in automotive. Why? Everybody is taking aircraft in a safe manner. We don't dream about a catastrophe when we take an aircraft. They put the level of risk at a level which is 10 power minus 9 probability per hour of a failure. That means the same level like a nuclear power plant. Okay, but recently there is a question. The number of aircraft flying in the planet is growing dramatically. It has been multiplied by 10 in the last 20 to 30 years, multiplied by 10. So there is a factor now that is becoming, if you calculate the number of flights, you could perhaps found that this calculation, 10 power minus 9, is not sufficient. So the question is acceptability of the risk by the community, by the planet, by the people, by the insurance, by the provider of the aircraft. The same occurs today in the thinking, in the strategic thinking of the automotive industry. Which type of function can we provide at which level of risk, and how much will it cost to provide 100% demonstration, quite mathematically, that you can reach a 10 power minus 9 number of accidents per hour. And in the automotive world, the number of running cars has nothing to do with the aeronautics. There is a factor of 1,000 to 10,000 more cars running on Earth. So each year, people are now calculating again and being afraid that really we are not able to demonstrate that this level of risk is acceptable for a company, for a car maker, acceptable for an equipment maker, acceptable for the citizen itself. Even people are thinking in terms of risk. Can you provide the fact that this car cannot kill people? Is integrating artificial intelligence in the use case, which people, if there is an accident, you provide to be safe? Is it the children crossing the road or the people inside of the car? So there are a lot of strategic thinking now in the calculation of the risk. And each time we do this type of calculation, we need more engineering people. I come back to my concern. We are not sufficient in the planet to develop so complex calculation and so complex demonstration. And people want to be safe. So my feeling is, yes, there will be a long time, because now people understand that to make the formal demonstration at the level of risk take a lot of time and a lot of engineering. And I think the product that is provided by companies like EasyMile will be products that we will have to use during a long time, in my point of view. This will be the only product that cities will provide to the citizen, in such a manner that you can have a full autonomous, I would like to say, mobility, very safe, because this has been calculated and prepared in the infrastructure of the city to be safe, like when you are making the use of a bus. So for me, the calculation and the effort will depend on how much energy and how much engineer and how much money all the planet can invest to make this formal demonstration. And each year we see this level of investment which is rising on the upper situation. So I don't know. I don't know.
Yeah, I really think the autonomy is going to happen, and 100%. And the reason for that is that connectivity is the missing ingredient. If you look at the statistics for driving, for example, in Berlin the average speed is 20 kilometers per hour. So the maximum speed is 60, but the average speed in the city is 20. And it's 20 because there are too many cars. So now imagine that you can connect the cars together, that they can agree on a common speed, that you don't have the same number of cars, that you have just 20% of the cars that we have today. Everybody is moving. There are no cars parked on the sides of the street, so the streets are wider for those cars. They could go now at 60 kilometers per hour, but we don't let them go at 60 kilometers per hour. We let them go at 40 kilometers per hour. That means we are twice as fast as we are today, but the average risk is lower because we are not driving at a maximum speed of 60, and the risk is proportional to the square of the velocity. It's not linear to the velocity, it's proportional to the square of the velocity. So that you get the best of both worlds. You get more speed and you get less risk. You get less energy in every car. If you make the cars lighter, then the possibility of killing someone also goes down because the car is lighter. So that I really think that the technology is going to get there, and I really envision a future, I don't know in how many years, 20, 30, 40 years, where there will be no humans driving cars.
Thank you. I think that I'm more on the line that we will see this autonomous driving depending on the situation. And I think that we shouldn't expect to have the technology to drive really everywhere in every no matter what condition with human drivers interconnecting. There is no business case on that. So actually, it will be nice from an engineering point of view, but we don't need that. We don't want that. But for example, what Raúl just told, this is something real. This is a benefit for a city, in this case like Berlin, and this is value that technology can provide. So I really see that we will have autonomous driving when it's really beneficial, meaning for this more smart mobility in the cities, meaning for our own private use on those situations where there is no fun to drive. And I think on that way, we need to live with that. And I heard that now the video could be played. So I would like to show it to you now, if it's possible. So this is a demonstration of one of the latest tests that we did, in this case in Australia. And what I want you to see here is not that we are testing autonomous driving, this is no, but we are thinking a lot about how to make a driver interact with autonomous driving. Because we think this is very important for the time being, as we have no level 4 or level 5, but even in the future, if we consider these limitations. So you see that we have a normal car with a lot of technology where this autonomous driving function is there. And for example, it will help when the driver is in control. Car-to-car communication, very important. That will make our lives easier, both when we are driving and when the car is driving. And this is where you see there comes a situation when the car says, okay, now I can take control. and the driver confirms, and now the car takes control. And the reason for the car now to be able, in this particular case, is because this is the area where we already have that very precise map. And if you get out of this area, then you will need to take control again. So, very interesting now the car is in control, but the car is still taking care of the driver and monitoring the driver, because there could come a situation where we need the driver help. So even if the car is driving by itself, is monitoring the driver. This is very important as well in the intermediate levels of autonomous driving, to have this safe interaction between the car and its capabilities and the driver, and how is it? And now it's coming to the end, and the car knows, because of the map, we are coming to the area where the driver has to take control. So we think this is quite a real picture of the autonomous driving that we will be seeing in the near future.
Thank you. Thank you very much. Well, I think now with all this interesting information and comments given by the panelists, there is no excuse. Let's open the questions and answers. And maybe, Antoni Fraser, that you are the organizing behind, you will have a question, by sure.
I have one question.
Yes.
May I,
Of
Chairman?
course, of course.
I have a question for Raúl. I mean, one of the key points of the autonomous driving will be the automatic braking, because the people will learn how the cars are reacting in case of very simple risk that you can feel, but sometimes you don't detect. And when you see that the automatic braking will be compulsory in the States and in Europe, braking at high speed, the motorway, not in the city, in the motorway.
Well, automatic braking at low speeds is already legal everywhere. So now automatic braking at high speeds, I think that it requires a lot of experience, a lot of testing in the highways. We had a case, for example, in the Mexico Drive, where there was a balloon floating on the highway, and then the car made a brake because it didn't recognize that the balloon is soft and then you can just go through. But so it's difficult to say, but it depends on the sensors and depends on the experience. And I think that we need millions and millions of kilometers of driving experience until you can make a radical change.
This is a general question, but at the end of the day, we have a roadmap. It's a long-term roadmap, but we need the steps in order to achieve our adoption of this self-driving car. From your consideration, what do you think that will be the first scenarios where we will see the self-driving car in a real life? It's about parking, it's about only highways, where we will find in order to really to buy it and to use it.
Where is the car maker to answer to this question? Where is? I want to see my customer speaking. We are ourselves providing the Lego technique of the technology in order to provide the entry of function to the market. The strategy of providing step-by-step functions is completely defined by the car maker.
Obviously, I cannot disagree with him because his customers are my customers, so I'm not going to disagree, but I think that we will see level 3 pretty soon, and there is a demand for the car makers, and this level 3 will happen on traffic jam and will happen on the motorway. Parking is a very special issue because in order to achieve automatic parking, you don't only need the car maker, but you need the infrastructure. And we are working on that, and this is where we come to the question about who's investing on that infrastructure. So there are some testing going on with private parkings combined with OEMs and technology providers like us that will very, very soon to already be able to provide this automatic valet parking.
Thank you. Then next question, please.
So question, I'm from Detroit in Michigan, so I see lots and lots of testing, but I've heard that one of the concerns that's happening is, and it happened to me too at the GM Tech Center, that as you're driving as a driver in an autonomous, when it directs you to retake over, you hesitate, like, well, should I really be taking over because the car's smarter than me? And they're finding this at Virginia Tech and other places. So are any of your companies building that hesitation factor into the human experience of the whole? I'm just interested in your comments of how that might play out in the future.
Thank you.
Is exactly what I show in my presentation. There is a modeling of the driver and the human-machine interface as a first element, I would like to say. This is the first element. Until we go step by step to automation, we need to have the driver in the loop, and we need to take care of the driver. What was shown also by my colleague is the fact that we detect that the driver is not having a normal behavior. He's becoming sleepy, or he's having a distraction. He's not looking with the eye to the road. He's looking on another area. So distraction, sleeping, all this type of thing is monitoring more accurately than never. Never. So I think the driver monitoring is the first function that you need to have in the cockpit of an autonomous car to go to the next step. Clear?
Fully agree.
Please.
Good afternoon, everyone. Well, you've talked about getting to a point where basically accidents are completely evitable, 10 minus 9, something like that, at an hour. But accidents actually happen. So where are autonomous vehicles today in comparison with normal driving? For example, in Spain, we have 1,500 deaths every year. So where will these autonomous vehicles today be in comparison with our normal driving?
Well, I would say that the autonomous cars today, they are far away of being safe and secure and as good as a human driver. That's why you don't see them outside in the streets. But I think that the introduction of autonomous driving in the highway first, for the highway first, is going to provide a lot of data, a lot of experience, and based on that data and that experience, what we expect is that cars will, on time, over many years, become even better than human drivers, but not today.
Please, Anthony.
I'm sure that the autonomous vehicle will be safety, but a question: when accident happens, who will be the responsible? The owner of the car, the car maker? Who will pay? And a second question is to test this kind of cars, we will need system to test. Where can the car makers test these cars? Because I suppose we need a special facilities.
Yeah, I will provide an answer for the second question. A lot of testing is actually done by simulation. I mean, engineers accumulate millions of hours of records using sensors in real situations, and then we try to replay those configurations in a computer and test the algorithms against those real-life conditions. Obviously, just by driving randomly, we cannot reproduce at will every single situation that can happen in real life. And unless we have 1 million test drivers driving days and nights during years, we will never be able to get that. So simulation is the key for testing.
Okay, Mr. Aguilera would like to ask something as well.
Just to complement to make some comments, I think there will be good places to test the cars. The cars will be a must to be tested and to be homologated, both things. We need to define a lot of new rules that are not yet well known in order to homologate and to certificate the cars, for sure. I mean, level 4, level 5 will need a lot of new testing in order to show that it fulfills this level of 99.99% of safety. That will be, it's possible to make the simulation, but simulation is close to 95, 6 or 7, and this 2 or 3% will be terrible. And for sure, all the OEMs will be obliged to test, to homologate, in order to certificate. And I think one example is what we propose as a Catalonia Living Lab, that we offer three good facilities like Idiada, the Castellolí and the circuit of Barcelona, Catalunya, with 7 special areas and road areas, city areas, transborder areas, etc., in order to test the car without driver. I think that will be a must, anyhow. I agree with you, but something more is needed.
Professor?
The professor.
Yeah, I wanted to say something about the insurance. One model which is being discussed in Germany is that when you buy an autonomous car, the autonomous car is already insured. So you don't have to buy a separate insurance. So if you buy a Mercedes, for example, the Mercedes comes with an insurance, and if something happens, you don't care if it was the computer or the car manufacturer or the software programmer who did the mistake. You get paid in the case of an accident, and the other people get paid. And then the companies look among themselves what was the error, like in the aviation industry. In the aviation industry, when you get into a plane, you are insured, but you are automatically insured. You don't have to go and buy insurance for that.
Okay, thank you very much, Professor. We are arriving to the end of the session. Then only 1 minute left, if you have something to say.
No, just to answer to the question of Mr. Anthony Freixa. Exactly what has been said. As equipment maker, we have to provide a system fulfilling the expectation, exactly which is defined and specified by the car maker, that is the architect of the full vehicle. And this will not change. This will not change. This will not change. Exactly in the past, we have to provide a system fulfilling the expectation of the car maker as a vehicle architect. This will not change. So in terms of the insurance, I think we have to provide ourselves the insurance for the faults that we can do during our process of manufacturing of the parts or the software development. But in terms of the delivery and in terms of the responsibility will stay as it is today with the car maker.
Thank you very much, Jean-Luc. Then we have arrived to the end. There is, I think we have been very, very lucky. It has been a luxury having this panel of really experts in this worldwide technology. And then I think we have seen in summary something that always we say as automotive engineers, and then from our society of engineers, is the automobile is always at the forefront of the technology, is always, let's say, looking and showing how technology advances, and this technology afterwards is applied to other fields. And then we are talking with autonomous vehicles. We have seen it's important to see that we cannot talk only about passenger vehicles. Then we are talking about passenger vehicles, urban vehicles, transportation vehicles, and all the fields of vehicles. Then I think that in our case, naturally, as I'm talking on behalf of STA, our society as well in Spain, in cooperation with a cluster of automotive engineers, with our local government, with our central government. Then we from STA, we have the stand of STA here, we are publishing magazines, and then we are always trying to push and help the industry and institutions to go further. Then for STA as well has been an honor that all of you will be here, and we hope that we could repeat this session, let's say, in the next future. Thank you very much.